I used to get stuck in geometry, seriously. A figure with a shaded area, like this one here for example, used to be my nightmare back when I was studying for exams, until I learned to see the right approach, and it became one of the easiest parts of the test for me. This problem here, for example, appeared on a civil service exam and tripped up a lot of people, but after you see how I solve it, you'll never get stuck on a question like this again. Stay until the end and comment if you got it right before checking the answer key. Let's go to the board. Here's what the problem says. In the figure below, there is a square with an area of 49 sampitu next to a rectangle, forming a figure with a total length of 16 sampiro. Inside the rectangle, there is a circle inscribed that is tangent to its top and bottom edges. What is the area of the shaded region of the rectangle, disregarding the area occupied by the circle? Consider pi to be equal to 22/7. Reading this statement already makes you nervous, right? You don't even know where to begin. Well, stay calm and pay attention here. The problem has already given us a lot of information that we can use to solve the problem. And the problem wants us to find this area right here. Look, this hatched area, in other words, this shaded area. Now, the big question, where do we start solving this problem? Take it easy, stay calm. I'm going to clean up the board here, organize it so we can solve things more neatly here. Pay attention. We want to find this area here. Look, this shaded area, this hatched area, right? To find this area, we first have to calculate the area of this rectangle, which is in green, then calculate the area of the circumference of the circle and subtract the area of the circle from the area of the rectangle. It's the same thing as if we had a sheet of paper and cut out the area of this circle and removed it from there. Only that outer part without the circle would be left, right? So we're going to do exactly that. We'll calculate the area of the rectangle. Let's imagine a sheet of paper. Then we'll calculate the area of the circle and subtract the area of the circle. We'll be left with just that little yellow area there. Well, and how do we calculate that? Pay attention. Let's go step by step here. In this figure that the problem gave us, there's a square there, this square that I just marked in yellow, which has an area equal to 49 square centimeters. Well, to calculate the area of a square, we calculate side squared, or side times side, right? Since we don't know the measurements of this square, I'll represent the sides of the square by x. Since the area is 49, then x squared is going to be equal to 49, okay? Yeah. Side squared is equal to the area, so x squared is equal to 49. Moving the exponent to the other side as a square root, we'll have x equals the square root of 49, and the square root of 49 is 7, so we conclude that x equals 7. If x equals 7, then the sides of this square measure 7 centimeters, right? 7 times 7 is 49, awesome. Well, since we've already found the sides of the square, notice that this distance up here from one end of the figure to the other is equal to 16 centimeters. Well, if the same distance is equal to 16 centimeters, consequently, the bottom edge will also be 16 centimeters. The measurements are the same. And we already know that the total length of the bottom edge, that is the base of the figure, is 16 centimeters. We already have 7 centimeters here, which is the side of the square. How much more do we need to make 16 centimeters? Well, 9 centimeters are missing, right? If we think a little, 7 plus 9 equals 16. All right, we've already figured out the length of the base of the rectangle. 9 centimeters. Now let's use our brains a little. Look, this side of the square here is equal to 7, right? If the square has all 4 sides equal, then this side here is also 7. So what do we conclude? That we've found the base and the height of the rectangle here, right? The base is 9 and the height is 7. That's exactly what we needed to calculate the rectangle's area, right? So let's calculate the area. Calculating the area of the rectangle, the area is base times height, where the base is 9 and the height is 7. So the area will be 9 times 7. Doing this multiplication, 9 times 7 is 63. The area of this green rectangle here, which we wanted, right, which we wanted to find, is equal to 63 square centimeters. Now that we already have the area of the rectangle, we need to calculate the area of the circle. To find the area of the circle, the formula is this one here. The area is equal to pi times the radius squared. And the problem already gave us here that we should use 22/7. It's right there, okay? Now, for us to find the radius of this circle, well, what is the radius? Here we have the center of the circle. The radius is the distance from the circle's edge to the center, right? Draw a straight line from the edge of the circle to the center. That's the radius. Now, how do we calculate it? Look, in the statement of the problem told us that this circle is tangent to the upper edge and the lower edge of the rectangle. That is, the circle is inscribed in the rectangle and it touches the upper edge and the lower edge. So, do you agree with me that if we draw a straight line here in the middle, from where it touches at the top all the way down, that's the distance, right? It's the same distance as the side of this square. These distances are equal from the top to the bottom, which is 7 centimeters. With that, we found the diameter of the circle, which is the distance from one edge passing through the center to the other edge. Now, since the radius is half of the diameter, we're going to take this diameter, which is 7, and divide it by 2, and we'll find the radius. I'm going to leave it in this fraction form, 7 over 2, okay? If we divide it, it will be 3.5, but we're going to work with the number with a decimal point, the decimal number. So, let's work with the fraction, 7 over 2. It will be easier for us to solve. You'll see later on. Well, if we already have the radius, the area is pi times the radius squared. So, let's go. The area will be equal to pi. Look, the question told us to use 22 over 7, so pi 22 over 7 times the radius squared. I left the radius as a fraction, 7 over 2, so 7 over 2 squared. Evaluating the power, the area will be equal to 22 over 7 times 7 squared is 49, 2 squared is 4, so it will be times 49 over 4. Now look how beautiful this is. On top there's 49, right? We have a multiplication of fractions. If we were to multiply normally here, we'd multiply the top by the top and the bottom by the bottom. But on top there's 49 and on the bottom there's 7, the 7. Should we divide 49 by 7? 49 divided by 7 is equal to 7. So, let's do this division right away to make it easier to solve, because now we're going to multiply 22 by 7, which is 154, and we keep the 4 on the bottom, so the area will be equal to 154 divided by 4. Solving this division, 154 by 4, that's equal to 38.5 square centimeters. This is the area of the circle. Alright, we already have the area of the rectangle and the area of the circle. Now I'm going to organize things here so we can find the hatched area, the shaded area. Alright, let me organize it here. The area of the rectangle that we found is 63 square centimeters and the area of the circle is 38.5. To find this shaded area, we're going to take the area of the rectangle minus the area of the circle, like I mentioned before. The area of the rectangle is 63 minus the area of the circle, which is 38.5. Solving this subtraction, 63 minus 38.5, that's equal to 24.5 square centimeters. That's the measurement of the shaded area, the area we were looking for in the rectangle, subtracting the area of the circle. So if you chose option B, you nailed it, you got the question right. So were you able to solve it before watching my explanation? Comment below which option you chose. If this type of question appears in your exam, you need to be here. In the next video, I'll bring more problems at this level, which are knocking out a lot of candidates in the final stretch. Please like the video, subscribe, and turn on notifications so you don't miss updates. Best regards from Professor Robson Lyers, Mathematicamente. Hope to see you in the next class.